Hello, how's it going? How we doing, people? Today on your notes, I don't know why it's not letting me move myself, so I'm just going to be in this bottom corner, I guess. You've got this piece of paper. We're going to fold it in half. So this is our front cover that says Writing Equations from Tables. Writing Equations from Tables. First, we've got some fill in the blanks. And it says, tables show the relationship between independent and dependent variables. You've probably heard those words in science class, independent variables and dependent variables. If I change the amount of bananas in my experiment, that might affect how the DNA is extracted. I was talking to Miss Bennett. She told me you guys were doing it in a lab like that in science. Or depending on what I pour on top of the bananas, I'll be able to extract the DNA better or worse or not at all. So that dependent variable, that whatever that liquid is that you're pouring onto the bananas, is going to change, or that independent variable, you're controlling how whatever you're pouring onto your bananas to then extract the DNA. That's your dependent variable. Your DNA extraction depends on whatever you're pouring into your bananas. You can use a table to write an equation that shows the relationship between those two variables. And that's the big thing for 7th grade, is being able to write equations from situations. In 6th grade, you guys just saw taking situations and putting them onto a graph, putting it onto a table, but now we're going to combine those two things together. They give us a situation here, and we're going to decide which one of these is the independent variable and which one of those is the dependent variable. The independent is the one that we can control. Katie eats 2 more cookies than her friend Jamie. Does Katie's cookie eating depend on Jamie? Or does Jamie's cookie eating depend on her friend Katie? Katie's cookies depends on how much Jamie eats. So Katie is our dependent variable because her cookies depends on what Jamie eats. So our dependent variable is Katie's cookies. And the independent variable then is Jamie's cookies. In 8th grade, you'll get more into the independent and dependent variable and identifying them. But for right now, just think about it like science class. Go ahead, pause the video if you need to finish writing in that information. Otherwise, if you're good to go, we're just going to get right into it. We're going to start finding the equation from a table. To write an equation from a table, we've got basically 3 steps. First, we need to find the pattern between the x and the y. We need to find the pattern between the x and the y. 7th grade, there's only 2 types of patterns. One is multiplicative, the proportional relationships you guys have been doing for the past 2 days, where we're multiplying or dividing that same number over and over and over again. The other one that we have in 7th grade is the additive relationship, where we're adding or subtracting the same number over and over and over again. That's what you're going to be working on next class. I wanted to spend today to have you guys see the differences between the multiplicative and the additive relationships before you get into the additive. So let's see if we can find the pattern here. I'm about to write this next part in pencil. The part that I'm writing in pencil, that's just my thinking because math is messy. I'm going to have some messy thinking before we figure out the work. So don't write anything yet. Wait until I'm writing in that purple pen again. So like I said, to find our pattern, to find our relationship, it has to be the same throughout the whole table. If one set of these x and y numbers does not follow the pattern, then it's the wrong pattern. The pattern has to be the same for every set in x and y values. Again, our pattern is going to be either multiplying and dividing or adding and subtracting. So let's think. What math could we do to go from 1 to 3? It's getting bigger, so I'm going to be adding or multiplying. I could do 1 times what would give me 3? 1 times 3 would equal 3. That pattern works for that row. But my pattern must be correct for everything for that to be my pattern. So that times 3 has to be true for the next set of numbers. Is 2 times 3 equal to 4? No. So that means this pattern of times 3 is wrong. 3 times 3, that's not 5. My pattern here is not times 3. So I'm going to erase that thinking. That was not quite right. So we need to find the pattern between x and y, adding and subtracting, or multiplying and dividing. So 1 times what would give me 3? No, I did do that right. Oh my gosh. Meow. 1 times 3 is equal to 3. Yeah, that works for that row, but it has to work for every single row. Is 2 times 3 equal to 4? No. Is 3 times 3 equal to 5? No. So I know that times 3 is not the correct pattern here. What else could I do to 1 to give me 3? Adding didn't work. Let's try multiplying. 1 times what? Or 1, excuse me. Multiplying didn't work. Let's try addition. 1 plus what gives me 3? 1 plus 2 gives me 3. I need to see, does that pattern work for everything? Does 2 plus 2 equal 4? Yes, it does. Does 3 plus 2 equal 5? It does. So that means that our pattern to go from 1 to 3, we added 2. 2 to 4, we added 2. From 3 to 5, we added 2. On every single one of these rows, we added 2 to our x to get our y. This pattern, yes, it is the same for all of these situations. Again, if just one of these rows was wrong, plus 2 would not be our pattern. Like if this said 3 plus 2 equaled 7, even though these two are right, because it didn't work there, it's wrong. It has to be the same for every single row. So in that relationship between the x and y, for our equation, we need to think, what was the same for all values? We're going to write a full sentence. We added 2 to each x to get y. Go ahead, pause the video so that we can get those plus 2's filled out and we can get that sentence written down. We added 2 to each x to get y. Go ahead, pause that video for a quick minute. All right, so for our equation then, our y values were equal to those x numbers plus 2. So that's going to be our equation. An equation is like a rule in math, a rule that every set of numbers for a relationship follows. To get all of these y numbers, we took our x numbers and we added 2 to them. That's how we write an equation. We just look for the pattern in the table. So our equation for this table is y equals x plus 2. It doesn't matter if we go to 100. If my x is 100, if I add 2, its y is going to be 102. If I go backwards to 0, 0 plus 2 would be 2. So we use these equations to help us see other numbers that aren't on the table. If you've gotten that written down, let's go ahead and flip to the next page. I should have got my nails done before I did this video for you. I apologize. So this page is big. There's a lot of stuff on it. We're going to continue with the tables. So up top, we're going to use these tables to help write an equation for us. So let's start with the bike rental cost, or rental bike cost, excuse me. So again, we have to find a pattern that works for every single one of these numbers. Again, I'm going to start off doing some math in pencil. Math is messy. My thinking is going to be messy, and that's okay. There is no shame in the calculator game. I am going to get out my calculator to help me out for this problem. Again, we're either adding. Ooh, there we go. Oh, you can't see my calculator because the way this is working. Okay. My bad. I'm sorry, guys. Here we go. I'll use my phone calculator. So we need to find math that's going to work for all of these situations. I think it's easiest to start thinking about addition. I learned addition first. It must be easier for my brain. So first I'm going to think 2 plus what number would equal 13? I can do that backwards. 13 minus 2 gives me 11. So that means that 2 plus 11 equals 13. That's true. But now I have to check and see, does it work for all of my situations? So now I'm going to come here and see 3 is 3 plus 11 equal to 1950? No. 3 plus 11 is not equal to 1950. Let's make this darker for y'all. 3 plus 11 is not 1950. So my pattern cannot be plus 11. I'm going to erase that. I'm going to try again. I can't do 2 minus something to give me that 13. That's not going to make sense. So I need to try multiplication. 2 times what would give me 13? I know that 2 times 6 gives me 12. I know that 2 times 7 gives me 14. So 2 times what would be in the middle? That would give me 13. What number is in the middle of 6 and 7? If here's 6 on my number line, here's 7. What's right in the middle there? 6.5, 6.5. Well, let's see if that works. If I do 2 times 6.5, well, that equals 13. 2 times 6.5 equals 13. Let's see if this is true for the rest of the problems. That's better. Let's see, is 3 times 6.5 19.50? It is. We do not write a 0 at the end, but we do when it's money. So 3 times 6.5 equaled 1950. What's 4 times 6.5? 26. 4 times 6.5 is equal to 26. So for all of these numbers, we took our x and did what to it? We did x times 6.5, and that equaled our y. That is not how you would see it written, though, in a textbook or on a test. Remember when you were solving equations, how you had the coefficient and the variable side by side? That's how we would write this. In a test, you would see this written as 6.5x is equal to y. When we have the coefficient and the variable, the 6.5 and the x side by side, that means multiplication. So this is 6.5 times x is equal to our y. Go ahead, pause the video if you need to finish writing that down. Write that thinking on the side. Again, math is messy, but if you see that strategy and you come across something like this in the future, you might be able to use it. Go ahead, pause the video and finish writing the notes. Okay, let's move on to the next one. Next, same idea, but now we're looking at Jake's age compared to John's age. Again, I like to start out thinking about addition or subtraction. Those work better for my brain. If you want to start thinking about multiplying and dividing, more power to you. Go for it. But I'm starting thinking about adding and subtracting. Again, I'm going to start with my pencil. My thinking is messy. 5 plus what would give me 11? 5, 6, 7, 8, 9, 10, 11. So 5 plus 6 is equal to 11. Let's see if this pattern works. What's 7 plus 6? No shame in the calculator game. Double check it. 7 plus 6, that equals 13. That's right. What's 9 plus 6? Does 9 plus 6 equal 15? It sure does. So this rule checks out with addition. So my equation is going to be, let me write this in pen first for you. 5 plus 6 is 11. 7 plus 6 is 13. 9 plus 6 is 15. Take a second, write that down. So Jake's age, doesn't matter how old he is. What can we do to Jake's age to get John's age? Jake's age, X, what can we do to it to equal Y, John's age? We did those X numbers and we add 6, and that will give us John's age. Go ahead, pause the video, finish writing anything you need to on your own. And now let's take a look at the next one. This next one doesn't have any titles like hours or costs, Jake's age, John's age, just straight X and Y. So again, it's the math that we're doing to the X to get our Y. What are we doing from our X to get our Y? I want you guys to try pausing the video and doing this one on your own. Think, are you going to add to go from your X to your Y? Are you subtracting to go from your X to your Y? Are you multiplying to go from your X to your Y? Or are you dividing to go from your X to the Y? And see, is that same thing true all the way through? Pause the video, try to find the pattern first. Once you've found the video, play it back so we can check to make sure you're right before you write the equation. Good luck. Try your best. Raise your hand if you have any questions. Did you try your rule for all 3 X and Y values? Okay, I hope so. So if I'm going from 12 to 7, do you think that's adding, subtracting, multiplying, or dividing? And then 10 to 5, and then 8 to 3. I can do 10 divided by 2 to get 5, but is 8 divided by 2 3? No. Is 12 divided by 2 7? No. So it can't be division. My numbers are getting smaller, so I'm probably subtracting. 12 minus what number would give me 7? 12 minus 5 gives me 7. That checks out. Let's see if it works the rest of the way through. Is 10 minus 5 equal to 5? Is 8 minus 5 equal to 3? It sure is. So on each one of these values, each one of these numbers, we're subtracting 5 from our X to get our Y. So now that we've found our pattern, what would the equation be? You can write your y second, you could write y equals and have it afterwards, whatever makes your heart happy. Pause the video, try writing that equation on your own. Hopefully you got that y is equal to our x value minus 5, or you could write x minus 5 equals y. Either one of those answers is correct. It doesn't matter if the y is first or at the end, just as long as it's on the other side of the equal sign as your x minus 5. Go ahead and wrap up anything you need to on that one. Otherwise, we're going to slide over here to write an equation from a graph. Betty makes t-shirts to sell. The graph below shows how much the t-shirts cost her to make. So on our, what axis is this at the bottom? The horizontal one? That is our x-axis. Our vertical, our up and down axis is our y-axis. So we can take this graph and we can make a table with the ordered pairs and determine the rule and find the equation. So we've got to remember, with our ordered pairs, our x number comes first before our y, and our x is how far left and right we go first. Our y is how far up and down we go. Important that we've got that figured out. We're going to be graphing for the rest of your math career. So these numbers on the side, they don't align very well with the little tick marks. So this tick is for 2, this tick is for 4, this one's for 6, this one's for 8, this one's for 10. This is where they start getting crazy. This one is for 12, this line's for 14, 16, and 18. So draw those lines to help you make sure you're reading the graph carefully, because otherwise you're going to get a wrong answer. So now that we know what numbers go where, now we're going to take a look and we're going to write our x and our y values for these ordered pairs, and then we're going to find a rule that works for it. So our first ordered pair here, this first dot, what is the x value that goes with this dot? The x number that goes with this dot is 2. So in this x spot, I'm going to write 2. What y value goes with this dot? Again, this is our y number on the side. Our y number is 4. Our next dot, the x for this dot is 4. Zoom out a bit for you. That's 4. The y is 8. This is why we drew those lines, because it's helpful. This y is 8. And then our last dot, our x is 6. Our y dot is 12. So go ahead first, make sure that you have your x's written down, 2, 4, 6, and your y's written down, 4, 8, 12. Just like before, we're going to find our rule. We just started with a graph instead of a table first. So again, we got to think, well, how could we add, subtract, multiply, or divide to go from this x to this y? What math can I do to go from 2 to 4? Again, I'm starting in pencil. 2 plus 2 equals 4. That's sure right. 2 plus 2 equals 4. Does it work all the way down? Sorry, I'm being like Dora. Did it work all the way down? No, why not? 4 plus 2, does that equal 8? No. Is 6 plus 2 equal to 12? No. So plus 2 is not our rule. So instead of adding, What other operation could I use? Subtraction, multiplication, or division to go from 2 to 4? Times 2, you say? Is 2 times 2 equal to 4? Mm-hmm. Is 4 times 2 equal to 8? It sure is. Is 6 times 2 equal to 12? It is. So what math did we do to all of our x's to equal our y? We did 2 times x. Remember, when they're side by side, that means multiply. So y is equal to 2x, or y is equal to 2 times x, or y is equal to x times 2. But this is the way you would see it on a test. Just get in the habit of writing it side by side. You save yourself a step by not drawing the dot. Go ahead, pause the video. Make sure you have all of those written down. Please ask any questions if you have. How did we get those x and y numbers? If we're figuring out these rules, please ask those questions, because the easier you make things for yourself now, the more successful you'll be when you learn more about additive relationships tomorrow. Go ahead, pause the video, get those things written down, and ask some questions. All right. We've got one more problem on these notes for today. Then you're going to have some time to practice on your own using this exact same strategy. So just like before, these lines are a lot better with the numbers, aren't they? Just like before, we're going to read these points, plug them into the table, find a rule and an equation. Go ahead, pause the video, or we'll do one more of the dots together, and then I'll have you do the other two on your own. All right. So for this dot, does x go up and down or horizontal side to side? X is side to side. X is horizontal. Y is my vertical axis, up and down. So my first dot is right here. What is the x value for that point? My x number on my x-axis is 2. Guys, draw a line down that helps me read that it's 2. And if I draw this line across, it's not at 4. It's not on this line at 4. It's not on this line at 6. What's in the middle of 4 and 6? 5. So that y value is going to be 5. Give yourself some space between these numbers so that you can write the plus, minus, multiply, or divide rule in the middle. Try these next 2 points on your own, and then I'm going to add in this point 2 for you. Add in that point for that extra box. We have 1, 2, 3 dots now. 1, 2, 3. Pause the video. Write in your x and y coordinates for those last 3 points. All right, this point, my x value is 6. My y value, what's in the middle of 8 and 10? 9. My next point, the x is 10. The y is in the middle of 12 and 14, so that means it's 13. And then this last dot here, our x is 12. Our y is 15. All right, we've got our points. Now we need to find our rule. Are we going to add, subtract, multiply, or divide to go from the x to the y? Pause the video. Try finding that out on your own. Did you try it on your own? Did it work for all the different rows? I hope so. Hopefully you saw that 2 plus 3 is equal to 5. That 6 plus 3 is equal to 9. 10 plus 3 is 13. 12 plus 3 is 15. So we're doing the same thing over and over and over again. So what is the rule? What are we doing to go from x to y every time? You add, 3. So our equation is going to be x plus 3 is equal to y. Or you can write the y first, or you can do y equals x plus 3. Either way, they mean the same thing. If you have any comments, questions, or concerns, please let us know. Otherwise, you can go on to the notes that practice this exact same skill. Use your pencil, do some messy math. If you get it wrong, that's okay. That's what a pencil's for. Just erase it and move on to the next thing. If you have questions, please ask them. Good luck today, guys.